Okay, so LeChatelier's principle. So it's named after French chemist Henri LeChatelier, who studied how equilibrium shifts because of changing some kind of conditions. So we've reached equilibrium, now we change something about the reaction. How does it then shift to reestablish equilibrium? So this is his principle. So it says, if a stress is applied to a system at equilibrium, that system will shift its equilibrium to a new position to counteract that effect of the stress. And we're going to talk about what those stresses are and how it shifts. So if a system is at equilibrium, it's going to shift to relieve that stress, that change you make to it, and it's going to reestablish a new equilibrium. So when it reestablishes a new equilibrium, you're going to have a different amount of reactant to product. So it's going to change that ratio. Okay, so these are the three stresses we're going to talk about. So let's say we change the concentration of our reactant or product. So we add more reactant to our reaction, or we remove some of the product. How does that shift our equilibrium? The second one then is, what if we change the temperature? So if we heat the reaction up, how is it going to affect it? Or if we cool the reaction down, how does that affect that equilibrium? And then the last thing we can do is, if we have things that are gases, we can change the pressure. So we can increase the pressure of the gas in the reaction, or we can release some of that pressure. And how is that going to affect the equilibrium? So we're going to talk about these three things. Remember, this last one only affects things that are gases. So you have to have gases in order for that last change to be affected. Because liquids don't change their volume. You can't squeeze a liquid to a smaller volume. The only thing you can change its volume is a gas. So change in concentration, change in temperature, change in pressure. Those are our three stresses we can apply to our system in equilibrium. Okay, so let's look at the first one. So changing concentration. So we're adding more product or reactant, or removing some product or reactant. So if we add a reactant or a product, it's going to shift away from that side. So let's say we add some reactant, we add more. I forgot that one, that's mark. We add more to our reactant side. Our reactants are always on the left. So if we add more, our thing becomes unbalanced, like up here, right? We're looking at the scale. So we have too much on this side, too much reactant. So what it's going to do is it's going to make some more product. So it's going to shift some of the reactant and turn it into product. So we could shift some of our reactant here. So I'm going to add 2 to the other side, and then it should become balanced again. So what's going to happen is A is going to react with B, and it's going to make more product, so that scale becomes balanced again. Okay, the same thing would happen if we were to do it in reverse. Let's say we add more product. So now we're adding more to this side of our reaction, to our product side. So it has to go in reverse. It has to make more reactant so it gets balanced again. So it makes some more reactant, and now it becomes balanced. So we would say it shifts to the left, or shifts towards the reactants. Okay? So if you add a reactant or product, it's going to shift to the opposite side, to whatever side you didn't add it to. Does that make sense? Okay? So let's talk about then if you remove something. So if you remove a reactant or product, it's going to shift towards that side. So if you think of it like, I'm going to take some of my product out, I'm going to lose some of it. Now I kind of have a hole on this side. Right? I don't have enough now. So I'm going to take some of my reactant and turn it into product to fill in that amount. So if we're removing product, it's going to shift towards the products. if we remove reactant, so we take some away on this side, it's going to have to shift towards the reactants to fill in what you just removed. So it's all about trying to get it to balance again. So if you add something, it shifts to the opposite side. If you remove something, it shifts to that side. So meaning it makes more products or it makes more reactants, depending on what you did. Okay, so let's try a couple examples. Is everyone good with this slide? So what happens to a reaction in equilibrium when reactant concentration is lowered? Okay, so remember we have our reactants. And we have our products. So it says we're lowering our reactant concentration. Okay, so we're removing some of our reactants. Which way are we going to shift? Towards the reactants or towards the products? So let's say we have 2 products, 2 reactants. Okay, and it says our concentration of our reactant is lowered. So that means we're removing some of our reactants. So which way do we have to shift to get it to balance again? Yeah, we have to shift towards our reactants. So it should be B. You got to fill in that hole where we just removed our reactant. So whatever side you remove from, you got to shift towards that side. So you could say it shifts left or it shifts towards the reactants. Okay, let's try another one. So what happens to a reaction in equilibrium when a certain amount of product is removed? Okay, so we have our reactants, we have our products, and we're removing some of our products. Which way do we have to shift? Yep, we have to shift right, or towards our products. We have to make more products to fill in what we just removed. So a lot of times chemical companies will do this to their reaction, right? As they don't want that reverse reaction. They don't want to make their reactants again. They want to make more product. So they'll start to pull off some of their product as they make it so that it keeps the reaction shifting towards that product. Okay, why don't you try this one on your own? See if you can figure out which one this should be. What is the effect of adding more water, so we're adding water, to our equilibrium? So your water is here as part of your reactant, so you're adding more of it. Is it A, more carbonic acid is produced, B, the CO2 concentration increases, the equilibrium shifts left towards the reactants, or the equilibrium is unaffected since water is a pure liquid? So adding more water. Okay, turn to the person next to you and tell them your answer. Okay, so we're adding more water, so we're adding more to this side of our equation. So which way do we have to shift?
Toward the reactant.
So we need to make more stuff on this side.
Toward the reactants.
These are your reactants. We're going to shift more this way. We want to make more of it. So it'd be like if we're looking at our thing here, we're adding more reactant. So how do I get it to balance again? What do I have to do? I need to add more here?
Right.
Yeah, so I need to add more what? Products. So I need to shift to the right. So it can't be C. Could it be A? Yes. I'm going to make more carbonic acid. Yeah. Yes, I'm going to make more of this on this side. Okay. Would my concentration of CO2 increase? No, it should decrease because I'm shifting to the right. Okay. So if you add something, remember you have to shift towards the opposite side that you added it to. Okay, try this one. What's the effect of adding more CO2 to the equilibrium? So you're adding more CO2 gas. So are you going to make more carbonic acid? Is the CO2 concentration going to increase even more? Okay. Is the equilibrium going to shift left towards the reactants, or the equilibrium will be unaffected? So remember, CO2 is here, so we're adding more of it. Okay, so turn to the person next to you. Explain to them what you think the answer should be. Okay, how many vote A is the right answer? You're going to make more carbonic acid.
I don't know.
How many vote B is going to be the answer? You're going to make more CO2. How many vote D? It's not, or C. It's going to move towards the reactants. D. It's not going to change. Answer should be A. So just like adding water, you have too much on this side now, so you got to make more products. So you're going to shift to the right. So it shifts right, so you're going to make more of your product, which is carbonic acid. Yes, question?
When will concentration increase?
So that means it increases even more than what it when you added it. So it would have to shift left in order for it to increase more. I should have probably changed that to water. Okay, so it's shifting right, so it should be making more of your product. So remember, the side you add to, it has to shift to the opposite side. Okay, let's talk then about how does temperature affect our equilibrium. So it's going to be the same, except now we got to think of heat like an actual substance, like CO2 or water. So if we add heat, it's going to shift away from whatever side heat is on. If we remove heat, meaning we cool it down, it's going to shift towards the side that the heat is on. So just like our reaction here, if we added more, it shifts away. If we remove, it shifts towards. Okay, now we have to figure out what side should our heat be on. So if we have an exothermic reaction, remember exothermic heat is leaving the system. So we have to think of heat like a product. If it's exothermic, right, it's exiting the reaction. If we have an endothermic reaction, we have to think of heat like a reactant because we have to add heat. Heat has to enter, endothermic enter. Okay, so we think of heat like a reactant. Remember, the delta H is the clue that tells us what side the heat goes on. So if delta H, it gives you a negative value like negative 25, that means heat has to be on the product side. If we have a delta H that's positive, okay, that means heat has to be on the reactant side because we have to add the heat. So otherwise it behaves just the same. If we add more heat to our exothermic reaction, so if we add more heat here, which way do we have to shift? To the opposite side, so it shifts left. If we remove heat from our exothermic reaction, which way does it have to shift? Towards that side, so it has to make more heat to compensate for that removal. Okay? If we look at endothermic, if we add heat, which way does it shift? To the opposite side, so it shifts right. And if we remove heat for an endothermic, it would have to shift to the left to make more heat, to compensate for you cooling it down. Okay, so if you add something, you shift to the opposite side. If you remove something, you shift towards that side. Okay, so let's try a couple examples. So for the reaction below, what is the effect of raising the temperature? So here it gives us a reaction. It says our delta H is negative 405. So is heat a reactant or a product then? So we have negative 405. That means heat is doing what? Heat is leaving, so it should be a product. right? If you have if you're losing negative $20, you're losing your money, right? If you have plus $20, you should be gaining money. Same thing with heat. If it's negative, you're going to be losing it. Okay, so we're going to raise the temperature. So we're going to increase the amount of heat. So does our equilibrium shift towards the right to make more product? Does it shift to the left to make more reactants? Or the reaction makes more of both reactants and products? So if we add more heat, which way do we have to shift? Yeah, we have to shift to the left. Because we have too much now on this side, so we make more of our reactant. Okay, why don't you try this one? Oops, I thought I had another one. So the last thing we can talk about then is what happens if we change the pressure. Remember, we have to have gaseous things for this to affect our system. So the relationship between pressure and volume is inverse. So if you increase the pressure on something, think about like squeezing a balloon, its volume gets less. Okay? If we decrease the pressure, then it allows things to expand, so our volume should increase. So this relationship plays a role when we talk about how we change pressure. So increase in pressure means you have to decrease the volume. Decrease in pressure means you can increase the volume. Okay, so here's the relationship then. So if we increase the pressure, we have to shift to the side with a smaller volume. This means it has less moles of gas. Okay, so if we're looking at this reaction, we get the number of moles of gas by looking at coefficients. So on the left or right side here, we would have 3 moles of gas. So here's our gaseous substance, the coefficient is 3. On this side, we have 2 gaseous substances. Each of them have a coefficient of what? 1. So together, they would have a total of 2 moles. Now, if this was a solid, okay, we only look at the gas, remember. So it would only have 1 then if that was a solid. So which side has the least amount of moles? Reactant side. So if we increase the pressure for this reaction, we would have to shift towards the reactants. So if we increase the pressure, because it has to shift to the side where there's less things. If you squeeze something, it gets to be a smaller volume. Okay, if we decrease the pressure, we will then shift to the side where there are more things, because now we have a larger volume. So we can compensate, we can make more room for those 3 moles. So we would shift, for this reaction, we would shift to the right. So increase pressure, you have to go to the side where there's less things. Decrease pressure, you got to go to the side where there's more things. What would happen if we were to have 2 and 2? So both sides have the same amount of moles. What do you think would happen?
The pressure stays safe.
So if we change the pressure, it's not going to affect our equilibrium because they would be equal if this was a 2. So if they have equal amount of moles, then there would be no change. So they have to have different amount of moles. Okay, let's try an example. So how does an increase in pressure affect the following reaction? So first let's figure out how many moles of gas we have on each side. So on our reactant side, how many moles of gas do we have? So we look at coefficient. So what number is out front here?
1, 3.
And we have what coefficient here? 1. So we have a total of 2 moles. Okay, what about on this side?
1.
Yep, coefficient here is 1. So we only have 1 mole of gas. Okay, so if we increase the pressure, that means our volume has to do what? Decrease. So which way do we shift?
Reactants.
To the reactants or the products?
Product.
Products, because products have less things. So you have to go to the side where there's less things. So we're going to shift to the right. Okay? So then you have to do the opposite. If we increase pressure, volume has to get less. So we have to go to the side where there are less things.
So if it was like decreased pressure and then rising, like increasing volume, would it be B now?
Yeah.
Okay.
Okay? Let's try another one. Okay, which of the following changes listed below would shift the equilibrium on this reaction to the right? So So we want something that's going to shift it to the right, so towards our product. So let's look at the first one. If we add chlorine, which is here, which way would we shift? To the right or to the left? Left, because we have to shift opposite the side we add. So it can't be A. What if we remove some of our oxygen? Which way do we have to shift? We have to shift to the left on that one still as well. So what if we increase the pressure? So increased pressure means your volume has to do what? Decrease. So how many moles do we have of gas on this side? 5. And what about this other side?
4.
So which way would we shift? Yep, to the right, to the side where there's a smaller volume. So answer should be C on that one. Okay? With your partner sitting next to you, I want you to answer these questions. So for each of these, you'd have to determine which way is it going to shift. So if you add chlorine, which way do you shift? If you increase the pressure, for B, which way are you going to shift? If you remove heat, and then D, if you remove PCl3. So figure out which way you're going to shift. Left or right or reactants or products, whichever one you like to use.
Would heat have a more than there?
No. It's only things that are gases. You don't want the gases.
I'm just like,
No. Okay, let's look at letter A. So if we add chlorine, so we're adding more to this side, which way do we shift? Left, yep. So you can either say we shift left or you shift towards your reactants. Either one would be acceptable. Whichever way you like to describe it. Okay, B. We increase the pressure. That means what has to happen to our volume? Volume decreases. So which side has less moles?
left.
Left. Yep, we only have 1 mole here. And then here we have our 2 moles of gas. So we have to go left. Okay, what if we remove some of our heat? So we take away some heat. What happens? Which way do we shift? Left. So we have to make more heat to fill in what we removed. And then D, what if we remove some phosphorus trichloride?
Right.
We have to shift right. Okay, any questions on those? You think we got it? Okay. So last thing, where can we see one of these reactions in real life? So your car does this, right? You add coolant to your engine to keep your engine cool. So if we were to look at the reaction that's actually going on, okay, we're taking some octane, if you have a really nice car, combining with oxygen from the air, and we make H2O, CO2 gas, and some energy. We give off a lot of heat. So if we were trying to keep our engine cool, right, we can get our car to work more efficiently. Because if we remove some of this energy, which way do we have to shift?
To the right.
To the right. So we have to combust more of that fuel. So we get a better combustion reaction if you can keep your engine cool. Because it's always going to continuously shift then to make more energy. And then a little joke here. So you can apply this, not to your chemistry homework, but maybe some other class. So if stress is applied to a system in equilibrium, the system will relieve that stress. So here's your homework. And there's you relieving the stress of too much homework. Okay, so let's go ahead and give it a try.